So here's another example of a mixed circuit. And yet again, if you don't know where to start, the first thing I always do is color code my pathways. I color code my pathways so I can see the different pathways that the electrons could travel on. So I'll have my green pathway, I'll have a red pathway, and I will have my yellow pathway. Now, if this is enough of a hint for you, hit pause and go ahead and try the question out. Whenever you're ready, you can simply hit resume on the video and see how I solved it. Now, there are multiple ways to approach this. Yet again, I'll tell you what my approach is, but yours could be completely different. First thing I'm looking at is I can see that over here at the power source, I have a resistance of 0.2 amps, and that represents all three colors. The other place where all three colors are traveling is through this 90 ohm resistor. So therefore, we know that we're going to have a current here of 0.2 amps. Now we know 0.2 amps represents all three colors. We also know that green represents 0.04. Therefore, red and yellow when combined have to be equal to 0.16 amps. Now from there we can see the pathway split off right here and either go straight down or all the way around. Now in the case of the red pathway, we can see that it's 0.10 amps. Therefore, we have to have a current of 0.06 amps here and 0.06 amps here. These are going to be in series with one another, so the current is going to be identical. We could have just as easily started with voltage. I chose to start with current. Now at this point, whenever I'm stuck on something, what I do is I start to look at the spots where I have two pieces of information, and I see if I can apply R is V divided by I, Ohm's law. So in this case, 90 ohms is equal to voltage divided by 0.2, which makes my voltage equal to, in this case, 18 volts. I'm going to do the same thing right here. And what I'm going to see is when yet again, I plug in R is V divided by I. I've got a resistance of 25 ohms, an unknown voltage, and a resistance of 0.06 amps, which means my voltage in this case is 1.5 volts. Let's go back to the idea we had a second ago. Between these two spots, you've either got the yellow pathway or you've got the red pathway. The yellow pathway we can see spends 4 volts. Therefore, in the same spot, we have to spend 4 volts as well. Now let's look at the red pathway as a total. We can see that it's spending 2 volts at its first resistor. It's spending 4 volts at its second resistor, so up to 6 volts. And then we've got 18 volts over here, which means the total voltage the red had to have was 24 volts. This is going to be true of every pathway. Let's take a look at the green pathway. The electrons go up, go through this resistor right here, go back down, then come through the 18 ohm resistor and comes back up. So when we look at it that way, that we see that there has to be 6 volts spent right here. And at this point, we've solved for everything, so I'm just going to hit pause and do all my resistance calculations. So you'll see I've completed this diagram, and all I did was I used R is V divided by I in every single case to figure out the unknown resistance.